Hi everyone, welcome back to PRAKASAM tutorials. In this video, we are going to discuss about concept of set operations. Set operations are the operations that are applied on two more sets to develop a relationship between them. There are different kinds of set operations that are union of set, intersection of set, complement of a set, difference between difference between the sets are relative component of the sets, and another one is symmetric difference, De Morgan's law, duality. So these are the different kinds of set operations. So first we are going to discuss about union of sets, and what is union of sets and how to represent union of the set symbolically. So union of the set. The sum or union of two sets, capital A and capital B, is the set of all the elements that belongs to capital A or capital B or both. So now here capital A and capital B are the two sets, and the sum or union of the two sets is the set of all the elements that belongs to set A or set B or both the sets. So symbolically, the union of the set is denoted as, this is the symbol of the union of the set. Union of two sets is denoted by A union B. So this is read as A union B. It is read as A union B. Union of two sets, capital A and capital B, and it is written as A plus B or A union B. And this is the Venn diagram of the union of the two sets, and this is the set A and this is the set B. So A union B, sum of all the elements belongs to both the sets. For two given sets, capital A and capital B, A union B is the set of distinct elements that belongs to set A and set B are both the sets. The number of elements in A union B is given by n of A union B is equal to n of A plus n of B minus n of A intersection B, where n of x is the number of elements in the set. Suppose, for example, to understand this union of the set, so let us consider an example. If set A is equal 1, 2, 3, 4 and set B is considered as 4, 5, 6, 7, then the union of A and B is given by A union B. So according to the definition of the union of the set, so what is the union of the set? The sum of two sets A and B, or union of the two sets A and B, is the set of all the elements belongs to both the sets. So A union B, sum means, so therefore A union B is uh, union of all the elements, union of set A and set B. So that is A union B is equal 1, 2, 3, 4, 5, 6, 7. So this is the example of the A union B. And second, okay, there are some important properties of the union of the sets. So that are, union operation satisfies the commutative law. So that is A union B is equal to B union A. So union operation satisfies associative law. That is A union B union C is equal A union B union C. Next property is union operation satisfies distributive law. That is A union B intersection C is equal A union B intersection A union C. Next property, union operation is identity law. That is A union universal set is equal to universal set. Capital A is the set A, and this is the union operation symbol, and this U is the universal set. A union null set is equal to A, and this is the union operation is the identity law. A union A bar A bar is the complement of set A. A union A bar is equal to universal set. So union operation is a identity law. A union A is equal to A. So union operation is identity law. So these are some important properties of union of the sets. And second one is intersection of the set. And what is the intersection of the set? The union of the set is the sum or union of the two sets that all the elements belongs to set A or set B or both the set. So now coming to the intersection of the set. The product of two sets A and B or intersection of the two sets A and B is the set of consisting of all the elements that are common to both the sets A and B. So common elements of set A and set B. That is the intersection of the two sets. So the symbol of the intersection is denoted as, this is the symbol of the intersection of the sets. The intersection of two sets A and B is denoted by A intersection B, and it is read as A intersection B. The intersection of two sets A and B is written as A into B or A intersection B. This A intersection B is also denoted as A into B. So intersection of two sets A and B or product of two sets A and B. The Venn diagram of intersection of two sets shown in this figure, and this is the set A and this is the set B, and this is the common elements between A and B, that is A intersection B. So that is the definition and Venn diagram of the intersection of the sets. For two given sets, okay, for two given sets capital A and capital B, so A intersection B is the set of common element that belongs to set A and set B. The number of elements in A intersection B is given by mathematically n of A intersection B is equal to n of A plus n of B minus n of A union B, where n of x is the number of elements in set X. So to understand the set operation, the intersection of the sets, let us consider the example, and the set A is considered as 1, 2, 3, 4, and the set B is considered as 3, 4, 5, 6, 3, 4, 5, 7. Then the intersection of A and B is given by, so from the definition of the intersection of the sets, so intersection of two sets is the set containing all the elements that are common to both the sets. So now here the common elements of set A and set B, the common elements are 3 and 4. So intersection of A and B is given by 3, 4. This is the example of the intersection of the set. And some important properties of intersection of the sets. The intersection operation is the commutative law. So that is A intersection B is equal to B intersection A. And the second property is A intersection B intersection C is equal to A intersection B intersection C. So intersection operation is associative law. Intersection operation is identity law. That is A intersection A is A. Intersection operation is identity law. That is A intersection universal set is equal to set A. Next property, intersection operation is identity law. That is A intersection A bar is equal to null set. So A is the set A dash is the complement of set A, pi is the null set. So intersection of A and complement of the set is null set. And these are the some important properties of intersection of the operation. And next operation is set difference. That set difference is also called as a relative component. The set operation difference between the sets implies subtracting the elements from a set, which is similar to the concept of difference between two numbers. Once again, the definition of the set difference or the relative component. The set operation difference between the sets implies subtracting the elements from a set. This concept is similar to the concept of difference between the numbers. The difference of A and B, capital A and capital B are the two sets. The difference of set A and set B are the relative components of set B in set A is the set of all the elements belongs to set A that does not belongs to set B. So this relative component of B in A is written as A minus B. The difference between the sets capital A and capital B is denoted as mathematically A minus B. So that is A minus B is equal A minus A intersection B. Okay. The difference of A and B, that is A minus B, is equal set A minus A intersection B. So let us consider, to understand the set operation of set difference better, let us consider an example. For example, the set A is defined as, set A is considered as 1, 2, 3, 4 and set B is considered as 3, 4, 5, 7. Then the difference between set A and set B is given by A minus B. So what is the A minus B? A minus B is equal to set A minus A intersection B. So first calculate the A intersection B. And what is the A intersection B? Capital A and capital B are the two sets. Using the intersection definition, the intersection of the two sets A and B is the set of consisting of all the elements that are common to both the sets. So A intersection B is the common elements of set A and set B. So first we determine A intersection B, and what are the common elements of set A and set B here? The common elements are 3, 4 are the common elements, that is A intersection B. Okay, now determine A minus B is equal to A minus of A intersection B, and this is the set A minus A intersection B is 3, 4. Subtracting set B from set A, we get A minus B is 1, 2. And then the difference between set B and set A is given by, so similarly the difference between set B and set A is B minus A is equal to set B minus B intersection A. So the intersection operation satisfy the commutative law. B intersection A is equal to A intersection B. Similarly also we can determine B minus A is equal to set B minus A intersection B. Okay. So first determine A intersection B, and A intersection B in common elements of set A and set B. And what are the common elements of set A and set B? 3, 4 are the common elements of the set A and set B. What is the set B? This is the set B. Subtracting B, subtracting A intersection B from B. Okay, we get B minus A is equal to 5, 7. So this is the concept of set difference or the relative component. Next one is symmetric difference. Okay, so from before going to the symmetric difference, now here we can observe that A minus B is equal to 1, 2. So B minus A is equal to 5, 6. So now here A minus B is not equal to B minus A. So hence we can observe that here the difference operation is not a commutative law. The difference operation not satisfies commutative law. That is A minus B is not equal to B minus A. And this is one more example. Next, coming to the next operation, symmetric difference. The symmetric difference of two sets capital A and capital B is defined as the union of the two relative components. So mathematically, and it is written as A symmetric difference B is equal A minus B union B minus A. Notice the definition: symmetric difference of two sets A and B is defined as the union of the two relative components. And what is the relative component? The relative component is nothing but a set difference. And what is the set difference between the two sets A and B, A minus B or B minus A? So union of two relative components. A minus B is the one relative component, B minus A is the second relative component. Union of the two relative components. That is A minus B union B minus A is the asymmetric difference of B. Symmetric difference of A and B. And the some important properties of symmetric difference of symmetric asymmetric difference A is equal to null set. Symmetric difference operation satisfy the commutative law, that is asymmetric difference B is equal to B symmetric difference A. A union B is equal to A union B is equal to asymmetric difference B symmetric difference of asymmetric difference B and A intersection B. And next property, A intersection B symmetric difference C is equal to symmetric difference of A intersection B and A intersection C. So these are some important properties of symmetric difference. And next operation is complement of a set. Capital A is the set A. The complement of the set A is denoted as symbolically A bar or A cap or A dash. And what is the complement of a set? The absolute complement of complement of a set A is the set of elements that belongs to the universal set and it does not belongs to set A, and it is denoted as mathematically complement of the set is represented as mathematically A bar or A dash or A cap. Hence A dash is equal x by x belongs to set A. More specially, A bar A dash is equal to universal set minus A. Now here capital U is the universal set that contains all the elements, all the objects. All the elements mean all the objects. The example of the complement of the set, to understand the set operation complement of sets better, let us consider an example. If universal set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 are the universal set and the set A is considered as 1, 2, 3, 4. Then the complement of the set A is given by, and what is the set A? A bar is equal to A bar or A dash is equal to universal set minus A, subtracting the set A from the universal set, and this is the universal set. Okay, this is the set A, subtracting the set A from the universal set. Okay, the set A is 1, 2, 3, 4. Okay, after subtracting from the universal set, a complement of the set A is 5, 6, 7, 8, 9. Next, some important properties of the complement of the set. A bar is equal to S minus A. A bar plus A is equal to sample space, that is universal set A plus A bar. Sample space, that is A bar is equal to S minus A. A intersection A bar is equal to null set. A union A bar is equal to universal set. A complement whole complement is set A. Complement of universal set is null set. Complement of null set is universal set. So these are some important properties of complement of a set. And next operation is De Morgan's law. The complement of the union of two sets is the intersection of their complements, and the complement of the intersection of the two sets is the union of their complements. Mathematically, it is written as, so the De Morgan's law states that complement of a union of two sets A and B equals to the intersection of the complement of A bar and B bar. So that is A union B whole bar is equal to intersection of complements of set A and B. So A bar intersection B bar. So this is also written as this one. Okay. So this bar is represented as dash. A union B whole dash is equal to A dash intersection B dash. The complement of intersection of two sets A and B equal to the union of the complements A bar and B bar. So that is A intersection B whole bar is equal A bar union B bar. So this is the De Morgan's law. The next operation is duality operation. The duality principle states that if any identity, all the unions are replaced by intersection. Okay, this is the union symbol and this is the intersection. The significance of the duality is all unions are replaced by intersection and all intersections are replaced by union, and universal set is replaced by null set and null set is replaced by universal set. So that is the significance of the duality concept. That is the duality principle. So then the identity is preserved that, for example, in the identity A intersection B union C. So A intersection B union C is equal to A intersection B union A intersection B. According to the duality principle, all intersections are replaced by unions and all unions are replaced by intersection. So now here on LHS side and RHS side, intersections are replaced by union, unions are replaced by intersection. We get A, this intersection is replaced by union, B, this union is replaced by intersection, C, A union B is A union B intersection C is equal to, on RHS side, this intersection is replaced by union and union is replaced by intersection. We get A union B intersection A union C. So this condition is also satisfied. A union B intersection C is equal to intersection of A union B and A union C. So this is also valid identity. And these are the set operations.